right, so let's apply some of the things that we just learned in this previous video to what we've got here. So part of what we're doing in this unit is connecting the numerical representation of a function to the graphical and to the analytical, okay? So starting out here, we are starting out, or we have been given a numerical representation for f of x. So we have all of our values of x, and then we have our values of what y is after you put x into the equation. So just a reminder here that if I ask you to tell me what f of negative 6 is, like if I asked for f of negative 6, that answer would be 8, which means this point, or this graph, goes to the point negative 6. All right, so from this table, we see that we have 5 different points that this function, lie on this function. So we could use this to graph these 5 points. So that's what I'm going to do right now. I'm going to graph the points negative 6, 8, negative 2, 3, 2, negative 2, 6, negative 7, there it is, and then 8, negative 9.5, which is a little bit less than what we've been doing. Okay, and then I'm going to connect these. I can see that these clearly form a linear function. Let me see if I can shift that a little bit. Not enough. There we go. Okay. I'm going to put some, let's do this. Oh, I don't want that. All right, there we go. Okay, keeps going forever. So now we've got a graph. And from this graph, we can now pretty easily tell what our equation is going to be. All right, so we know that we have the idea analytically. This is a linear function. It's in the form of f of x equals a times x plus b, where a is the slope, right? And b is the y-intercept. All right, so I can tell from here that my slope, if I just go between 2 points that I can see, my slope is change in y, so down 5 over 4, down 5 over 4, down 5 over 4. So my slope is negative 5 over 4. So this would be f of x equals negative 5 over 4x plus, I can't really tell what my y-intercept is. It might be 1/2. I don't actually know. So, or it might be something a little bit different than 1/2 because my thing is not drawn completely right. So, yeah, we're going to do this instead. We don't know what it is, so we're still going to call it b. But the beauty of this is an equation that determines all of the points on this graph. So if a point, or if an ordered pair is on this graph, the x and the y should work in the equation. So I can take any point here, any point over here. I'm going to pick this one just because I like the looks of it. 3 is my favorite number. So I'm going to take the point x equals negative 2 and y equals 3, and I'm going to plug it in over here. So remember, f of x is our y value, so that's going to be my 3. I'm going to plug in a negative 2 for x plus b, and then I'm going to work it out and solve for b. So this gives me 3 equals 5 over 4 times 2. Negative 5 over 4 times negative 2 gives me positive 10 over 4 plus b. And then I'm going to subtract 10/4 from both sides. So over here I have 3 minus 10/4, which is 12/4. That's 3 minus 10/4. That gives me b. So that's 2/4. So b is 1/2. All right, so now I can rewrite my equation. My analytical equation is f of x equals negative 5/4 x plus 1/2. We know now for sure that that's crossing at 1/2. Right? Perfect. Okay, so now we have all 3 representations. We've got numerical, we've got graphical, and we've got analytical.